session for today is SQL Server encryption, transparent data. We're gonna talk about transparent data encryption and cell-level encryption. This actually someone. I'm not gonna discuss this slide since Asif already introduced me. This is actually a special session because someone in our in our Facebook group asked for this session. They asked if we can have a session about encryption. So we do listen to you guys when you do suggestions and feedback. So here's the encryption session that you asked for. Today we're gonna discuss about the encryption hierarchy in SQL Server. If there's one thing that if there's only one thing that you can take home from this session, I hope that would be the one, because that will be the basis of everything, all the mechanisms and all the process of encrypting in SQL Server. And then after that, we're going to talk about the different keys available for you in SQL Server, as well as the algorithm that you can use. And then we will focus on transparent data encryption, what it is, how you can set it up, and why, what it is for, when to use TDE. And then if we have enough time later on, we're gonna I'm also gonna show you about cell-level encryption. Before we go deeper, there are a lot of security features and encryption features for SQL Server. They address different kinds of scenarios. So if you are enabling them, make sure you understand the requirements that you have, the policies that you are trying to achieve, to meet, so that you can use the right feature for it. Because each one of them addresses a different requirement. So let's talk about encryption hierarchy. I'm gonna discuss the simplest path for encrypting in SQL Server. So it all starts with the Windows operating system. SQL Server is on top of the Windows OS, so it's using the DP API, the Data Protection API for the Windows. It's a Windows component that handles all the security and encryption on the OS itself, to make sure that any components of the server belongs to it, or it is the one that can create symmetric keys and that can encrypt the keys that you have on the server to make sure that it belongs to that specific hardware. So the DP API encrypts the service master key. The service master key is created when you install SQL Server. When you install SQL Server when you do the installation, the service master key gets created and saved on the Windows on the SQL Server binaries. So DP API encrypts the service master key, and then after that, you create a database master key. This one resides on the master database. Master database is one of your system databases for SQL Server. So it is one of the databases that first comes online when you start a SQL Server, when you start the SQL Server service. That's why the database master key resides on the master database, so that it can read the key and decrypt everything after it. So the DP API encrypts your service master key, and the service master key encrypts your database master key. So after you have that, this is important. So one thing to note, the master database cannot be encrypted, because this is the first, like I said, it's the system database. It contains all the configuration of your SQL Server. So if you're going to encrypt it, it's going to be complicated and problematic on how you can decrypt the master and bring the instance online. So master database is the one responsible for decrypting everything else below it. And then we have certificates. So from here, a certificate, if you're familiar with a certificate, it has a public key and a private key. So Everything else on the instance, you can on the SQL Server instance, you can use the certificates. From here on down, you can have either a certificate, a symmetric key, or asymmetric key, so that you can use that to encrypt all the your data on the database level. There is a special symmetric key for SQL Server. We call it database encryption key. Database encryption key is a symmetric key that resides on the user database level. It is only used for TDE. So the database encryption key resides on the boot page of your user database, so that when you start up the database, it knows when it finds the key, it can decrypt the data that is within the database. So this is the usual path, but you also have the options of encrypting your certificate, your encryption keys using a password. Later on, we're going to discuss what's the advantage and disadvantage of using a password to encrypt your certificates and keys. You can also, if you can see here, you also have the option to password protect your database master key, and you also have the capability to keep all those keys outside of SQL Server using an EKM module. So this is just an added security. You can store your keys on a separate location from your data to make it more secure. You can use something like Azure Key Vault to hold your keys. One thing to take note, if you are doing EKM module, make sure the connectivity between your provider and your SQL Server is reliable. Yeah, so these are the other ways you can encrypt. Later on, we're going to discuss the differences between them and the advantages and disadvantages. So let's go to the encryption mechanism. So you see earlier we have symmetric key, asymmetric key, and certificates. So we'll first discuss about symmetric key. Symmetric key is the fastest among the three. It's also the simplest because it uses a single key for encryption and decryption. Like I mentioned, it's the fastest among the three. So if you're gonna do encryption for for your transactions, right, that you need to do a lot of time within the day, or you're gonna use multiple times during the day, or for your activity, for your transactions, right? This is the best option among the three because it's faster. In terms of algorithms that are available for you, these are all the currently available algorithm that you can use. Just word of caution, DES and RC2 is already deprecated. You're supposed to be using AES already. The RC encryptions have been cracked and broken a long time ago. So this is only here for backward compatibility. If you are still using it, you should be re-encrypting your data to a more secure algorithm. DES is also there. If you secure, remember you have an option to secure it with a password or a certificate. If you secure a symmetric key with a password, it will be encrypted using the DES encryption. So if you look at here, for symmetric key, it can be encrypted. You can encrypt a symmetric key with more than one mechanism. For example, if you want to encrypt it with a password, a certificate, and a symmetric key, you can do that. But if you encrypt it with a password, it automatically becomes a DES algorithm. So even if, for example, you're encrypting it with asymmetric key with an AES algorithm, but if you put a password, then after that it's going to be encrypted with a weaker algorithm, which is DES. There are three types of DES available for SQL Server: the triple DES and triple DES 3 key. The only difference is the number of bits for the keys. So triple DES has 128 bit, and triple DES 3 key has 192 bit. Yeah. And then we have the asymmetric key. Asymmetric key uses a key pair. It's more secure than symmetric key, but the downside is it's also more CPU intensive. Among the three, this is the most resource intensive among the three mechanisms available. It also you can encrypt your asymmetric key using the RSA encryptions, the RSA algorithms from 512-4096. The end numbers are just the number of bits. So the higher number of bits for the keys, the harder it is to crack, and the more complex the algorithm is. So it's more secure. I think SSL uses I think SSL uses 1024 or 2048. So it uses the similar encryption algorithm as SSL. And then you can encrypt an asymmetric key using a password or a master key, which is the default. Certificates, it uses the same thing. It's a key pair, a public and private key. The private key is the one that can decrypt the information. Public key is the one that you can distribute to that the clients can use to encrypt the information. So for SQL Server, you have an option to use a self-signed certificate, or you can, if you have an existing certificate server on your environment, or you are using a different certificate provider, you can bring that to SQL Server. Just one thing to note, for SQL Server, it doesn't do the revocation and validation of your certificates. The only important thing for SQL Server is the subject and the name and that the certificate exists. Usually, for example, if you have SSL, you have a expiration date. When your certificate expires, usually for SSL, your site becomes unavailable. You cannot use the certificate anymore. For SQL Server, especially for self-signed certificate, the expiry date doesn't matter. It doesn't check the expiry date. So by default, when you create a self-signed certificate for SQL Server, it will default the expiry date to 1 year after you created the certificate. But even after that, for example, if you use that certificate for your TDE, it doesn't affect the availability of your database or the certificate. But if, for example, if you have any policy on your company that requires the expiry date to be on a certain date, then you can do that. You can change the date on when you create the certificate, or if you're going to use the certificate for other purposes than signing for SQL Server. In terms of algorithm for certificates, the self-signed certificates are using SHA-256. For imported certificates, as long as the private key is more than 2.5 kilobytes, SQL Server will accept the certificate. I won't mention this anymore because it's deprecated. It's no longer in use. It's still available for 2016, but by right, you should be using the newer algorithm, which is SHA-256. And yeah, you can encrypt your certificates using the database master key and the password. And then we have the database encryption key. As I mentioned earlier, it's a special type of symmetric key. It's still a symmetric key, but it's only used for TDE. And unlike the other keys, it should reside on your database, on the user database level. It's used for, like I said, it's used for TDE. In terms of encryption, you have AES-128 and AES-192. The default is AES 256. In terms of encryption, you can encrypt the database encryption key with a certificate or an asymmetric key. So that brings us to TDE. So TDE is encryption at rest. What it does is it encrypts your database at the page level. So once you turn on TDE, the data files and the log files gets encrypted, and then what happens is as soon, for example, you have a transaction. When you let's start from the start. When you open the database, if it's encrypted in TDE, once you bring the database online, it will check if the database encryption key is on the boot page of that database. If it is, it will start to decrypt the data and put it on the buffer pool. If for any reason it cannot find the database encryption key, or it cannot decrypt the database encryption key, then your database won't come online. So everything on the buffer pool is decrypted, but everything on the file itself, once it's hardened, for example, if you have a transaction, once it's written on your log files, it will become encrypted. The page at the page level, and then once that transaction hardened, the data on the database file gets encrypted. So since the data is encrypted at the page level, when you take a backup, since it doesn't bring it, when you do a backup, it doesn't bring it up to the buffer pool anymore. Your backups are automatically encrypted. Once you turn on TDE on a SQL Server instance, your TempDB automatically will be encrypted. This is because to preserve this is because some of your data, when you read it for the user database, right, you might put it on the TempDB. So to preserve the encryption, so to meet the requirement that it's always encrypted at rest, your TempDB becomes encrypted even though only one database on that instance is encrypted. So it can be an advantage or disadvantage depending on how you look at it. So once your TempDB is encrypted, even if you, for example, you turn off the TDE on the database, you have no more database on your instance that are on TDE, the TempDB will still be encrypted until you restart the SQL Server instance. One thing to take note, file stream data on your database, even if it's enabled for TDE, is not encrypted. This is because, as you all know, the file stream data resides outside of the database files and database log files. It's on the file system, so it's not part of the TDE. Also, if you have TDE on, or if you're using any of the encryption keys mentioned earlier, any of the encryption, you cannot use it together with you cannot create a backpack or a backpack for it, because you need to remove the encryption first before you can do a before you do a package. So let's take a look on how we can do this so that we can see it at work and we can understand much better. Let's take a look here. I have here a database. Let's start from the start. I'm going to restore the database. It's just a backup of my SQLPASS. It's just a version of Northwind. Nothing special with the database. So let's do a restore. All right, before we do, let's take a backup. I just want to show you something. So one is compressed, one is not. One of the backups has compression enabled, one doesn't have. So if you look at the backups, these are the normal backups. We haven't encrypted the database yet. So this is the the uncompressed backup, and this is the compressed backup. And you can see the space saving that you have. This is just a small database, but imagine if you have a larger database. It's a best practice to turn on compression so that you can save space and storage. Later on, we'll find out later on why I highlighted that information. So let's take a look at the database. It's just a normal database. Just want to show you that there is data on the table. So if we go to certificates, I should not have one yet. So these are all just system certificates for other stuff on my SQL Server instance. So if we take a look at the symmetric keys, you can see here the service master key. You can take a look at the date. That means I installed the SQL Server instance on 11/30/2019. The timestamp for all the encryption information for the symmetric keys, certificates, and asymmetric keys are in UTC. And you can see here there's a modified date. See, if, for example, I change the SQL Server service account, the service master key also gets changed. Or if, for example, there's a change in the hardware, there's too much change on the OS side. For example, you changed CPU, you added a lot of CPU, you changed something on the OS, it gets modified. So I don't have any master key. If we do this, there's none there. So I'm going to create a master key. Here I'm going to encrypt it with the password. It is required, by the way, to have a password for your master key. And you should be storing it somewhere safe once you created the master key so that you can use it later on. So if we go back to the table, you'll find the database master key and the service master key. And you can take a look at the date. See, it's not 1927. Oh, they changed. It's already. Oh, that's. I always thought it's on UTC. All right, so let's create a certificate. Create certificate, my certificate. So right here, I didn't specify any password or any encryption mechanism. That means it will create it. It will use the master key. I'm still on master. So it's created. Once we go to the certificates, you can see the new one created here, and you can see it's encrypted by the master key. So yeah, so we encrypted by master key. There's a private key last backup date here, the issuer name, and here the expiry date. You can see it's 1 year from now. Oh, and here you can see the date. It's in UTC. It's no longer in. It's not. I thought also the master key, but it's okay. It's only for the certificates. All right. So I'm going to create a database encryption key so that we can turn on TDE on this on the TDE demo. I'm going to encrypt it with my certificate that we just created. You can. There you go. So you can see the warning here. The certificate used for encrypting the database encryption key has not yet backed up. So it's reminding you that you should be backing up your certificates. Why? Because if you lose this certificate, anything anything from here. For example, you lose this certificate, you don't have any backup, you don't have any way of recovering it. You won't be able to unencrypt your whatever you use it for to encrypt. For example, if you use this to encrypt a column, you won't be able to decrypt that column if you lose the certificate. Same with with TDE. You won't be able to decrypt that database encryption key that we created if we don't have a backup. So make sure you always back up your certificates. So before we proceed, let's take a backup of that one. So here I'm backing up my certificate to this file, and this is the private key, and I'm encrypting that backup with a password. So now we're ready to encrypt TDE demo. So the things that you need when you want to encrypt, when you want to turn on TDE, you need to have a master key in place, and then you need to have a certificate in place. So now let's create. I'm gonna include this section. You can see here it's, oh, let's go back here. Let's check if it's updated. We already took a backup, so if we go here, you can see here the private key last backup date. So if you go to the file system, there's my backup. So yeah, so now that we have a backup, let's turn it on. I'm gonna include the select key here. This is the DMV for your database encryption key. I just want to show you guys that you can see because the database that we're going to encrypt is quite small. So I just want to capture the encryption in progress. So let's do that. Let's turn on TDE for this database. You can see here, 10th DB is now encrypted. It's by default 256. And then for TDE demo, you can see here the encryption is in progress. So like I said earlier, the data is encrypted at the page level. So it's not instantaneous. It's not when you turn on encryption, when you set encryption on, it's not automatically encrypted. It will take some time for the whole file to be encrypted. So you can monitor the progress on this DMV. If you have a larger database, it will take some time. If we go back here now, it should be done because it's just a very small database. See here, it's encrypted. And you can see the key algorithm here. It's the same as we specified because we encrypted the database encryption key with AES 128. So now the database is already encrypted. If we select the data, you can still select it the same way. There's no change on the user side. For example, if I'm the user, there's no changes needed for my side to view the data. There's no schema changes that I need to do for TDE. It's just like its name, it's transparent. So it doesn't change any of the data on the table. The encryption is on the storage itself. So how does it protect you? If someone gets a hold of your backup, or if someone gets a hold of your storage, for example, someone gets a copy of your database, they won't be able to open it or restore it on a new instance unless they have the certificates. So let's do a backup and take a look at that. So I'm gonna back up the database, one with compression, one without compression. And then I'm just gonna detach the database so that we can try and attach it to another instance. All right, so it's already backed up. If you look at here, if you look at the backups, see here, once your database is encrypted in TDE, the backup compression is more or less negated. You can see the difference here. It's almost the same size as the encrypted, the uncompressed backup. This is because there's not much more to free up when it is encrypted. So it's one of the, well, you can think of it as a disadvantage of TDE. Backup compression is already it doesn't work once TDE is enabled. So let's try and attach that database to a different instance. I have another instance here in my machine, a SQL 2019 Express. So if I attach that file, for example, someone gets a hold of your MDF and LDF file and try to attach it to a new instance so that they can read the data, they won't be able to because they don't have the certificate. If I try to restore the backup, let's give you the same thing. You'll receive the same error if you have an encrypted backup for the backup encryption itself. So you won't be, if someone gets a hold of your backups or someone gets a hold of your MDF and LDF file, they won't be able to use it without the certificate. That's what TDE is protecting you from. It's encrypting your data on the storage level. So the question is, can we restore it to a different instance? If, for example, we are the valid users, we own the database. Yes, you can. Remember, you need the certificates. So on this instance, let's see. I shouldn't have any. I don't have any certificates. Wait, let me just. Did I connect to the? Yeah, I connected to the kernel. So I don't have any certificates here, right? So symmetrically, I only have a service master key. You don't have a master. Don't have a database master key yet. So let's create a master key. And then what you can do is you can export your certificate that you backed up earlier. You can name it however you want. It doesn't matter because it's importing the certificate itself. What's important is this file, the certificate and the private key. And you should know the password of the backups of the certificate backup. So I'm gonna create this certificate. And look at here, there is an error, right? So it says the key file is not valid. So this is because, remember I said earlier on, if you look at the certificates, this is part of the security mechanism for backing up your certificates. Whenever you back up a key from SQL Server, if you look at the keys, see here, even if it's authenticated user, we are an authenticated user, you don't, but we cannot open the file itself. That is because it's tied to the SQL Server account. If you look at here, same with the certificate itself. So if you look at here, MS SQL Server, that's the service account that I have for that instance, for the original instance. So only that one, even if it's on the same it's on the same machine, the permission is tied to the SQL Server the SQL Server service account. So if you look at here, my default instance and the SQL Server, the SQL 2019 Express different service account. So you still have to grant that permission. So to make it faster, I'm just gonna grant to everyone. Same with the other certificate with the private key. See, it's only MS SQL Server and the administrator. But even though so let's grant the permission to everyone to make it faster. But you can also just grant it to the service account itself of the new instance. So when we come back here and try to create the certificate again, now it allows us. Now let's try and restore it again. So if you try and restore, you can see here it allowed me to restore the database. That means it was able to read the backup file. I just want to show you this thing because TDE is only available for Enterprise Edition and Azure SQL databases. So you need to be on Enterprise or using Azure SQL database for TDE. So if we go back here, yeah, so here we don't have any more, on the original instance, we don't have the TDE anymore, right? So if you go here, there's no more TDE, but we can restore that because the original certificate is still on this instance. If we restore that, we will be able to so if we restore TDE demo, for example, there you go. And if you do a select, if you use TDE demo 1, you should be able to read the data. So that's how TDE works. So going back, so some points to remember: make sure you back up your keys and certificates. If you lose any of the keys from database encryption key, the certificate, the master key, if you lose any of those, you won't be able to decrypt your data. The advantage of TDE is you don't have to change anything on the schema. In terms of performance, there was they did a benchmark when TDE came out. They compared it with the performance of a database before TDE and after TDE, and they saw that change in performance is just around 2 to 3%, which is a lot lower compared to CellLevel Encryption, wherein they see a 20% to 30% increase degradation in performance. But those benchmarks were from before SSD, so it's a lot lower. It should be a lot lower now, if not negligible. The advantage, yep.
Sorry, we have a couple of questions. Maybe I think you can just answer those. The first question is, what about other databases, DB and model, and how to generate the key, and do you need to put the DB in single user before enabling TDE? You can see in the chat window.
Let me just, you need to put the DB in a single user before. No, you don't need to turn the database into single user mode. The encryption happens in the background, so you can still use it. You can still use it as it encrypts. And then Warner said that on 2019 it's already available on standard. Also does it support column level encryption? You can use column level even if your database is on TDE. You can still use column level encryption. Is certificate also needed if we enable the TDE on Azure DB or the key from Azure Key Vault will secure the TDE Azure DB. For Azure SQL database, you don't need to create it manually. It creates it on the background. You can just go to the Azure portal and go to the security features and just turn on TDE, and then it will create the necessary keys for you. That's the advantage of putting it in a PASS of using a platform as a service. So plain data is readable. to admin and data reader. So as you saw earlier, it doesn't encrypt the data on the table. You can still select it the same way as you've always as with database without TDE. So one thing to take note, it's not encrypted in transit. Like I said, it's encryption at rest. If you need it to be encrypted in transit and at rest, you need to use a different feature for SQL Server, like always encrypted or secure enclave. Or if you really want to use TDE, you need to enable SSL on SQL Server so that the data is still encrypted in transit. Backup compression, like I mentioned, what we saw on the demo, it's negated. It's not. It doesn't compress backup efficiently. And yeah, 10 TB is encrypted for all databases in the instance. So that's the advantages and disadvantages also of a TDE. And then someone asked a question about column data encryption, cell-level encryption. So the difference is cell-level encryption encrypts the data on the table itself. The value is stored as encrypted. You have to use an encrypt and decrypt function to be able to do that. And it requires a schema change because the encrypted value is in var binary. So I still have 4 minutes. Let me quickly show you guys how we do. So for column level, we have here the SQL, this table, the employees table. I have an NRIC here. Maybe I need to encrypt that if I'm storing it on the database. So let me just check. Let me just clean it up. So I don't have any certificate. Let me create. Let me don't have any master key. Okay. So let's create a new certificate. Remember, on the encryption hierarchy, you can use encryption by password. So this one, we're gonna encrypt the certificate with a password. And then it should be there. So there's my certificate. It's still not yet back up. So I'm gonna use that certificate to create a symmetric key called NRIC key. If you notice for this one, we weren't prompted for backing up the certificate. That's because you're encrypting it with password. So you should keep this password somewhere safe. So like I mentioned earlier, you need to do some schema changes if you're gonna encrypt by cell level encryption. We are going to add an NRIC encrypted var column, which will be var binary. And then here, every time you use a symmetric key, if it's password protected, or a certificate if it's password protected, you need to always provide the password. So we need to do this. We need to update symmetric key, so open the password, and let's do update. We're just gonna encrypt the NRIC column using the NRIC key that we create. Now your new column now has the encrypted value for NRIC. You can verify that by decrypting the column itself. Here we're decrypting NRC encrypted. I'm gonna call it NRC encrypted column so that we can verify if the information is the same. And there you go. So you were able to encrypt that. You can store it as encrypted, but you need to use the function the decryption in the open symmetric key decryption by certificate, so that you can do that. One thing to take note here, you cannot use open symmetric key function, but you can use it in a stored procedure. And here is the downside of using a password, like I mentioned earlier. Every time you use the key, you need to provide the password. So if you create, for example, you use it for a stored procedure, you need to store that password on that stored procedure. So it might be it depends on how you on your requirement. It's possible to encrypt by password, but you need to be aware of those details. So if we go, yeah, so that's how you use the CellLevel. Uh, Earlier, there's a question if you can use it together with TDE. Yes, there's no, you can do that.
Hi, Pio, sorry to interrupt.
Yeah, sorry, I just muted everyone else.
Yeah.
That's better. So yeah, so that's a cell-level encryption. So if you compare the two, they have different usage. So just a quick summary before we open for questions. So we've discussed the encryption hierarchy, the available keys for you, what's TDE, how to do it, and what you should be using it for. And then we've discussed column level encryption. What's next? There are still a lot of things on the encryption side. We still have always encrypted row levels. If you want to do encrypted address and in transit, that's always encrypted. And then row level security, if you want certain data to just be available to certain users, you can use that. And then we do have data masking if you want to display the data differently, to mask your data, so that when someone select it without the proper permission to unmask it, they won't see the information. So that's what we have. For the resources, we're gonna share it later on. And yeah, that's all. Do you guys have any more questions? Yes, the recording will be on our YouTube channel. If you haven't subscribe to our YouTube channel. Is this support for that one? I'm not sure. That's a good question. I'll check, then I'll get back to you on that. I'm not sure if there will be. Any other question?
Yeah, about that question about homomorphic encryption, that closest thing that is available is if you do always encrypt it with a secure enclave, which is like the latest and greatest technology right now for encryption for SQL, right? Because if you enable always encrypted and you're using hardware that supports a secure enclave, then you can do rich computation on the encrypted data, right? So then you'll be able to do whatever you want in terms of, well, not whatever, what Microsoft has implemented in terms of SQL operations on encrypted data, but they remain encrypted even in RAM, right? Because the only decryption that happens is inside the CPU chip, and then it goes back out through the wire encrypted, and then it finally gets decrypted as well at the client, right? So it will give you the same result as if you had done the query against the unencrypted data without revealing the data to anybody except to the CPU chip itself.
There you go. Yeah, so thank you, Warner. There's another question here. Can you use log shipping with TDE enabled database? TDE is compatible with availability groups and mirroring and TDE and log shipping. The only thing to take note is before you do it needs to be all the certificates need to be in place before you do the restore, so that the database can be restored on your log shipping subscriber or on your secondary replica or on your mirror. So you need to put all the certificates in place first before you do the restore. And yeah, so gonna take a 5-minute break. Wait, let me just show. And then we're gonna start at 8 p.m. for the next session about Synapse Analytics.